Dear students, my name is Jordan Simonov and I would like to present a topic called Warfare Use of Pesticides, Toxicity of Agent Blue. During the Vietnam War, Agent Blue and other herbicides were sprayed by US military forces at a very great amount with the purpose to kill crops and deprive Viet Cong and North Vietnamese troops of food and to remove the vegetation cover used for concealment. Agent Blue was used in South Vietnam for rapid defoliation, grassy plant control, and rice destruction. More than 4 million liters of Agent Blue were dispensed in this military rice killing operation. Agent Blue contained 4.7% carcodilic acid, which is 54% arsenic. The routes of entry of carcodilic acid in the human body are by ingestion, inhalation, skin and eye contact. Carcodilic acid is more readily absorbed into the bloodstream when inhaled. It's metabolized by the liver and bioaccumulates in it. The mechanism of toxicity of arsenic include enzyme inhibition and oxidative stress, as well as immune, endocrine, and epigenetic effects. The acute adverse and chronic health effects are discussed in the presentation. The symptoms and signs which appear due to the exposure poisoning to the arsenicals are listed. The diseases promoted by arsenicals, including different types of cancer, are listed also. This is the title page for presentations of the Erasmus project TOXOR, Learning Toxicology through Open Educational Resources. And now, let us go back on the topic and include some more details. During the Vietnam War, Agent Orange, Agent Blue, and other herbicides were sprayed by US military forces at a rate of magnitude greater than amounts used for domestic weed control. They were mostly sprayed over South Vietnam forests to kill crops, to deprive Viet Cong and North Vietnamese troops of food, and to remove the vegetation cover used for concealment. Agent Blue was used as a contact herbicide in South Vietnam for rapid defoliation, grassy plant control, and specifically for rice destruction. More than 4 million liters of Agent Blue was dispensed in the Department of Defense (DoD) herbicide program. Here is a map of the large region of Agent Blue warfare application. Agent Blue works by rapidly defoliating or desiccating a wide variety of plant species of grasses and grains. It works by uncoupling phosphorylation in plants. It was used in situations requiring rapid defoliation, causing browning or discoloration within 1 day, with maximum desiccation and leaf fall occur within 2 to 4 weeks. By starving rice plants of moisture, the enemy, this includes millions of rice-growing villagers though, would be deprived of their most basic food. This is an interesting photo of the rice killing operations in Vietnam with the Agent Blue. US soldiers attempted to blow up rice paddies and rice stalks by using mortars and grenades. Although grains of rice were very durable and were not easily destroyed, every grain that survived was a seed to be collected and planted again. Soon, the rice killing operations became more sophisticated. Rubber or plastic bladders were dropped directly into rice paddies, exploding on impact and releasing toxic herbicides. Barrels of herbicides were also dropped into the water, irrigating rice paddies, polluting rivers and poisoning the soil and people for many, many years. The groundwaters of the Red River, alluvial tract in Hanoi, Vietnam, are anoxic and rich in iron due to naturally occurring organic matter in the sediments. The problems are caused largely from tube wells, which pull water from depths of between approximately 10 and 40 meters. The wells designed to provide safe drinking water by avoiding polluted surface waters accidentally tapped into arsenic-contaminated underground aquifers. The use of Agent Blue during the Vietnam War and other industrial developments caused the levels of bioavailable arsenicals to spike dangerously. The toxicity of Agent Blue. Agent Blue contained nearly 5% cacodylic acid, also known as DMAA, and nearly 30% sodium cacodylate as the active ingredients. Cacodylic acid is a colorless, odorless, hygroscopic crystalline solid and is 54% arsenic. Besides DMAA, another organic arsenical compound, which form the active ingredients of pesticides and herbicides, used mainly for weed control, is monomethylazoic acid, MMAA. MMAA and DMAA are also metabolites of inorganic arsenic formed intracellularly by most living organisms, animals, plants, and bacteria. Molecular structure of cacodylic acid. The term Agent Blue was first applied to cacodylic acid in a powder form that was mixed with water in the field. Cacodylic acid is a highly soluble organic arsenic compound that readily breaks down in soil. It is considered to have very low toxicity to mammals. The commercial form of Agent Blue was among 10 toxic insecticides, fungicides, and herbicides partially deregulated by the U.S. Environmental Protection Agency, or EPA, in February 2004, and specific limits on toxic residues in meat, milk, poultry, and eggs were removed. The World Health Organization, WHO, guidelines for safety limit of arsenic is at 10 microgram per liter in drinking water. In Vietnam, though, the legal arsenic concentration limit is 5 times higher than in the WHO guidelines. The routes of entry of cacodylic acid are by ingestion, inhalation, skin and eye contact, and absorption through the skin. Cacodylic acid is more readily absorbed into the bloodstream when inhaled. It is metabolized by the liver and bioaccumulates in and is excreted by skin, nails, and hair. Unlike inorganic arsenicals, DMAA and MMAA do not bind strongly to molecules in humans. Hence, their acute toxicity seems to be less than that of the inorganic arsenicals. The mechanism of toxicity of arsenic include enzyme inhibition and oxidative stress, as well as immune, endocrine, and epigenetic effects. At the end of the presentation is the closing page of the ToxOur project, where you can see the logos of the participating educational institutions from 7 European countries.